Hello, you're welcome to our second tutorial on control system. You can check up on our first tutorial on control system, that's on feedback and introduction of control system. Today we are going to learn about Laplace functions and Laplace transformations. Okay, engineering got interesting, so let's study engineering with fun. Let's go. Laplace transformation. Basically, what's a Laplace transformation? We can cast our mind back to engineering maths. Laplace transformation was used to minimize or to convert complex differential equations to simple polynomials. Okay, but here we are not going to talk about converting complex differential equations to simply polynomials, but we are using it to solve life problems. Okay. So here, Laplace transformation of a signal is defined as f of t, where t is less than or greater than, is less than or equal to 0, that's t, and greater than infinity. Okay, in this function, that's when t approaches less than or equal to 0 or greater than infinity. And to a change or to a transformation of f of s, this will give a change to s of f. Okay, so let's start the journey. Let's start the journey in calculating Laplace transformations. Okay, let's go. Laplace transformation. So the basic formula for a Laplace transformation is Laplace. You write your Laplace into this parenthesis bracket. That's f of t is equal to with these three signs, is equal to the function, the Laplace function, and equal to what? An integral of as t approaches infinity and as t approaches 0. Okay, and you have the exponential of negative st, okay, times f of t different times the t. So this differentiation with respect to t. That's why I said is approaching when t is approaching infinity and t is approaching 0. So this is the basic formula we are going to use in our Laplace transformation equations and a whole lot. Okay, let's go. So basically, this is a simple Laplace transformation. This you have to put it in your mind. Okay, so in a simple question that they can be given, they can give you that find the Laplace transformation. Find the Laplace transformation when f of t is equal to 1. Okay, this will be our question. Okay, this will be our question. How do we go about it? I'll teach you very simply how to go about it. Engineering got very simple. Let's make it. Okay, our data is that they said when f of t is equal to 1. So we quote our Laplace formula. Laplace of f of t, if you remember, is equal to capital F of s. Sorry, I didn't define this capital. We have f of t and we have capital F of s. So f of t is a function with in terms of time. It's a function in terms of time. And this is a function in terms of Laplace. In terms of Laplace. Okay, so this is a capital F, this is a small f. So take note. Okay, that's something you have to note. So it gets interesting. Let's make calculation get more interesting. So you prove to them engineering is the best subject. Okay, so let's continue. Yeah, as the approaches f, capital F of s is equal to integral of as t approaches infinity and as t approaches 0. So exponential of negative st into bracket or multiplying t, multiplying what? F of t, okay, the t. Okay, yeah. So right now our formula, they gave us f of t here as 1. So let's put it inside. Your Laplace function, that's f, that's small f, Laplace function of t, that's 1, is equal to f, capital F of s, is equal to integral of this, that's infinity and 0, if exponential of negative st, f of t and the t. This is the simplest way you can understand this. Okay, so let's follow and understand it very well and better. So this is something simple. I'm going to make it very simple for you. Just fingertips, so it to be on your fingertips. Okay, so there is it. Instead of the f of t, do you know what you do? You put your 1 there, because they say f of t is 1, multiplying 1. Okay, is that right? Watch it carefully. F of t. So let's imply this one and solve with this side. So anything multiplying something, one with multiplying every equation or every value is the same now a value. So let's say x multiplying 1 is the same x. Okay, so let's take note. So in differentiation and integration, let's cast our mind back to integration and differentiation. What did we learn? We learned how to differentiate or integrate exponential value. Okay, exponential value, you can integrate it, very simple. So we have, when they say we should integrate this negative s with respect to the t, how do we do it? It's very simple. Take your time. This, you differentiate this and multiply it by this. That's all. Differentiate this negative. If you differentiate negative st, what are you going to get? You are going to get 1 over negative s. Okay, and multiply it by the same thing again. You are done. You are done. It got simple. You are done. Let's continue. So that's the differentiation of that. So let's put inside. When we differentiate only this, what do we get? We get 1 over negative s e exponential of negative st. Yes, that's good. Can you imagine you solve this in very simple? Let's continue. You did like this, like this. You bring this and bring this. So right now, what do you have to do? You have to insert it inside and get our final equation. So when you have something like this, it just simply means wherever you see t, you put this, and subtract it from wherever you see t, you put 0, and you are done. Okay, so let's continue. So let's open our parentheses or bracket. 1 over negative s e with exponential negative s approaches infinity minus 1 over negative s approaching what? 0. Okay, you are subtracting. Basically, just put it to your mind. This is 0. This side is 0. Why? Why is this side 0? 0 because this what is infinity. This infinity. You see, this infinity plenty number, 1,000, 1 billion, millions. Okay, so we can represent this by 1,000. So when you put this here 1,000 times this, exponential of that will give you 0. A lot of decimals. So we consider this as 0. Okay, so let's deal with this side. Negative become positive, so you get 1 over s. Okay, exponential 0 times this is 0. 0 times every number or everything is 0, so you get 0. So anything raised to the power 0 is 1. Okay, anything raised to the power 0 is 1. So multiply it by 1, multiplied by 1. So 1 times this is what? 1 over s. So therefore, we are done. Relax. Our transformation function, our Laplace transformation function of f of t, with respect to time, where time is 1, our Laplace transformation is 1 over s. That's good. Very simple.